All right, we are covering section 8.4 and then the first half of 8.5 today. So this is going to be the 8.4 part of it. We're going to go and come back to 8.1 and 8.2 at the very end of this. 8.3, 8.4, 8.5, 6, and 7 all kind of tie together, and then 1 and 2 can be done independently. So compound interest. Compound interest is simply another way to earn your interest. That's it. It's just another way, instead of getting your interest applied once at the end of your period, it gets applied, it gets split in compoundings. Okay? And there's one formula that you're going to need to know to start, and that's A equals P 1 plus R over N to the NT power. Now, as you can see, many of the variables look the same, and they are. The A is still accumulated or future value. The P is still the principal, what you put in initially. The R is still your interest rate as a decimal or a percent converted to a decimal. The T is still your time in years. And then we have a new variable. And this new variable is in two places. It is N, number of compoundings, and it will change depending on what they say. There are several types of ways that you can get your interest applied. You can have your interest applied annually, which means that your N is 1. You get it once, okay? And that essentially amounts to simple interest. You can have your interest applied semi-annually, meaning that your interest rate, I don't even know why I wrote annually in here, we can just write semi. It means your interest rate is divided into 2. Good. It doesn't mean you get 4% twice a year. It means that you get 2% after the first half of the year, 2% after the second half. Now you may be wondering, what's the difference? Well, if you put in money initially, and then 6 months later, if it's a semi-annual case, it earns 2%, then it sits there a little bit longer at a higher rate, at a higher amount. And then, at the end of the year, 2% more is applied. It grows just a bit more than if you waited that whole time not earning any interest and then get applied at the very end for 4%. And you'll see some of those problems. Then we have quarterly, which is 4. Monthly, which would be 12. Good. And then we have daily, which would be 360. So 360, they're not going to go off of 365 days in a year, they'll go off 360. Your 30 would actually technically be a monthly situation, right? So those are the 5 ways when you see a problem that asks you to calculate the future value on a compound interest scenario with P, R, N, and T being certain variables. When you get to the end, you interpret it as a 1, 2, 4, 12, or 360, depending on the situation you have. Does that make sense, guys? Okay? I'm not going to do this first problem. I'm going to skip ahead because I don't really like the annually scenario. It's too easy. But what let's do is let's do the semi-annual case. All right? So let's take a look at this. We want to figure out if we deposit $8,000 into a bank account or whatever, an investment, the interest rate is 7%, compounded semi-annually. Over 2 years, what will that $8,000 grow to? Okay? And so this is a compound interest problem because we see this key part, compounding. In the previous section in simple interest, you didn't see any compounding. Therefore, you know you're not dealing with a compound interest problem. Does that make sense, guys? Okay, so to get started, A equals P, 1 plus R over N to the NT because we're looking for the future value, right? And so our future value is going to be what? $8,000. 1 plus the interest rate, not 7 but 0.07. There you go. Divided by 2 because your N is 2. Compounded semi-annually, 2, twice a year. To another 2, it's in 2 places, times 4. Okay? So that's your setup. Make sure you understand initially where to place things. Now, as I said in the last class, you need to have a scientific calculator. It's not good enough to be using your phone calculator. You need to have a scientific calculator. Otherwise, you will struggle heavily in this chapter.
Where did you get the 4 from?
What's the T? Sorry. My bad. I was already doing the calculation. Thank you for calling that out. All right, there you go. It will become 4. You will struggle very, very heavily if you do not have a scientific calculator and are not able to work it smoothly. You have to be able to work it smoothly. So if you are not prepared with a calculator today, it is not a good thing. You must be able to run it with a calculator. So why? Because I'm going to show you how to run this calculation. The first thing you do, you should do the 0.07 divided by 2. 0.07 divided by 2. What is that? Somebody got that part? 0.035. Now, don't write it down necessarily if you don't want to, because you can do a couple things all in one step. After you find this part, you can immediately add 1 to that. What would that become? 1.035. Done. And at the same time, we can calculate that. 2 times 2 is? The 4. Okay? Any questions about that at all? You need to be able to do this on your calculator yourself. If you are without a calculator right now, you're not in a good position because you are going to get back to your homework and you are going to fumble around and struggle with getting these numbers. Okay? So make sure you are able to do this. Now, next thing, the product of these is not what you do next. It's always this step. And you're going to see this happen over and over and over again. Now, I can't calculate this to check for you, but because my phone's recording, but you guys need to, somebody needs to find out 1.035 to the 4 so everybody else can figure that out. What is that?
1.1475.
Great, 1.1475, and does it keep going on?
Yes.
Okay, perfect. So you calculate that, 1.1475, and so on and so on. Then hit the multiplication sign. You don't want to round, if you can help it, until the very end of the problem. You do not want to round, unless you can help it, until the very end of the problem. There will be some later today that we have to round, but if we can help it, you just calculated this, leave it there in your calculator, hit the multiplication sign, and then what?
Get 9180.1840005.
So 184, so therefore it doesn't round up on the 8. There it is. And that's your answer. Let's hope it's correct. It looks pretty good. So 9180.18, is that right?
Yes.
And there it is. Okay? Very, very good. Now, once you figure that out, we know that we can also calculate how much interest we earned. The interest we earned is always what? How much the account grew to minus what? The principal, exactly. So the amount of interest that you earned is the difference between your future value and your principal. That's the difference there, and that's your interest. So in our case, the future value was 9180.18. The principal 8,000, what we put into the account or deposited. So 1180.18, that should be your interest. And let's just check it, 1180.18, and we're good. Does that make sense, guys? Any questions about that at all? And that's how you do compound interest problems. Now, I am not going to do every single one, but we are going to do another one. So, as you can see in problem 3, I'm not going to do this one, okay, but I want to talk about it real quick. Your principal is 2,500, so your P would change. Your rate is 4%. Your R would change. Your time is 3 years. Your T would change, and very much so, it's compounded quarterly. What would your N be for this problem? 4. Okay? So pay very close attention to your work. I'm not doing this one. I just wanted to discuss it. All right? Now, let's take a look at the next one. There's a monthly. What would the N be for this one? 12. Hopefully you were seeing that. Now, let's do this one. This one I want to do. All right? Is this still going? All right, wonderful. So, we are going to do this one. They're asking us for the future value. Okay? Asking us for the future value. I want you to set that up on your own. Make sure that you can set this up all by yourself. They say the principal is 9,500, rate 7%, compounded daily this time. Time is 4 years. Set up the equation to ensure that you can at least get started with calculating the future value of this investment or deposit. Okay?
Compound is the N, right?
It is, right. Your compounded is your N. So A equals 9,500. 1 plus your R just happens to be the same interest rate from the previous problem. That doesn't matter. Your N is what now? 360. Good job. All to the power of N, 360 times T. I'm not going to make that mistake again. 4 this time. Any questions about this? There's your setup, right? That's your setup. Now, do you think we go and solve it the same way in the same steps as the previous one? Yeah, that's why they're sitting right next to each other. Because it's so important that you know what to do first. And what comes first is 0.07 divided by 360. Now, remember what I said. If you're working on this internet class or this class here, the less that you round and have to go and type things back into your calculator, the better of a job you're going to be doing. Okay? So what you want to make sure of is 0.07 division sign 360. That should give you an answer. Then we need to add 1 to that. What do we get when we add 1 to that? Somebody.
1.00019444.
Okay, fine. 1944 and so on. And so just for now, I'm going to just leave that there. Now, real quick, what's 360 times 4? And that's going to be 0, 24, 1440. What you should do right now is, if you need to, take 360 times 4 on the side. That way you know it. So that then do this part. Does that make sense? So that you can then take this answer exactly as it appears in the calculator, hit your exponent 1440 so that you can get a very exact answer. However, if you didn't do it that way, at least take your decimal here and go as far down when record that so that when you type it back in, you get a very long, so you're not estimating too little. What you don't want to do is just do 1.0 or 1 to the 1440. Does that make sense? You want to make sure you are getting that correct. What is this? What do you get when you do this to the 1440 power? Somebody got an answer for that?
Yes.
Just say it out loud.
12,000.
Well, hold on. Well, okay, well, why don't we just get the answer? 12,000 what?
569.39.
Did you round the 9 correctly?
Yes.
Okay, wonderful. Do we have a confirmation of that?
Well, in this situation, would you round up or round down? Do you always round?
It's always round up. We'll round to the nearest hundredth, right?
It was 0.391.
Yeah, it's-
so
391, so that's perfect.
Yeah.
Or it was 391 or 38?
391.
Okay, so 391. So answer, let's see, 12,569.39. That looks good. Nice job. Wonderful. You should make sure that you're able to get these answers. If you are not able to, you need to ask questions now. Okay? You need to know how to use your calculator. You need to know how to get those answers. And so what do? We calculated this, then we hit the multiplication sign, 9,500, and got that answer there. Okay? Now, how do we calculate the interest? Same way that we did before. I equals whatever your future value is minus whatever you put in. So in this case, it's 12,569.39 minus 9,500. And so that should be what? 3,069.39, right?
Yes.
There it is. All right, any questions about that at all? Please ask. Madonna, it's still going? Awesome. And you got your answer? Did you get the answer? Okay, good, wonderful. All right, great. Now, I am not going to do number 6. As you can see, it's another very similar problem, except it's a bigger principal, a little bit smaller rate, compounded daily, longer amount of time. Doesn't matter, you would handle it the same way as we just did, okay? So let's move on. Now, what I do want to do next is this one. This one's a very important problem. And it says find the accumulated value, aka future value, right, of an investment of $10,000 for 3 years at an interest rate of 5% if the money is A, compounded semi-annually, quarterly, monthly. I don't want to do all these. Those are just separate problems, right? It's just another way of doing the stuff we just did. There's your principal, there's your time, there's your interest rate, and all they're doing is changing the N and wanting you to recalculate that. Does that make sense, guys? What you're going to find is, so long as the principal, time, and rate stay the same, the more compoundings you get, the little bit more money you have at the end. Does that make sense? The more the compoundings, the more the money. And when you go and do this yourself, you'll notice that. But what I do want to do in this problem is part D. That looks different. And it is. And so what we're going to do is have another note here, continuously. Okay? So when you see compounded continuously, you need to use a different equation. Compounded continuously is a different equation. When you see compounded continuously, your equation is A equals P times E to the RT. There is an E button on your calculator. There is an E button on your calculator, and that's what we're going to be using. Okay? So you really need to make sure that you can find it. Otherwise, you will never get the continuous compounding problems right. And they're the easiest ones. They're a piece of cake. Okay, so let's take a look at this problem. And so what I want to do is, let's do it right here, okay? So we have A equals P E to the RT, all right? And so compounded continuously. Well, let's take a look here. P is what?
10,000.
10,000, there's your P. So your future value in a continuously compounded account is your principal, in our case, 10,000. There's no E because that's part of your calculus. That's a button. It's a constant that you do not need to find a value for. It's not necessarily a variable. R, your interest rate, right? What's that?
0.05.
0.05. And then your time, 3 years, okay? So your time is 3 years here. Now, let's go through the steps for solving this. The first thing, just like we did before, we would calculate if there was anything in parentheses, we do it, but there's not, so then we do the exponent. This would be what? 10,000 times e to the 0.15. Does that make sense, everybody? Now, if you have a calculator, now's the time to calculate e to the 0.15. There are 2 ways to do this on a calculator. One way, some calculators, you put the 0.15 in first, then the e, and then it gives you your answer. It should be 1 point something. Other calculators, e goes first, then the 0.15, then hit the equal sign. Does somebody have an answer for what that is?
11,600.
Oh, hold on. We'll do that in just a moment. That's good, Adil. It sounds right.
It's 1.161.
1.161 and so on. Make sure you're able to get 1.161. I wanted to take a break, Adil, because I wanted people to be able to check that they got the E part right? And of course, if they got the 11,000, it means they got that right too. But just as a middle step. So 1.1 something. Everybody agree? We good? Okay. All right. So now, once you do that, then hit your multiplication button, right? Just like you would have done before. 10,000. And now, Adil, read it off.
11,618.34.
618.34? Okay. That sounds good. And there it is. Any questions about that at all? Wonderful. Now, obviously, I can't put it in here to check because I have to do parts A, B, and C first. But I can tell you that's probably right. All right? Now, question for you. If I wanted to find how much interest we earn, would we do it the same way as the previous problems? Yeah, you would, right? Because if this is the future value, and I want to know how much interest I earn, well, then I just subtract the principal from it. Does that make sense, guys? But I'm not going to do that because you already know how. So whether you're dealing with standard compound interest or continuously, or that special case of continuously compoundings, to find the interest earned, it's done the same way, but to find the future value, it's different. You with me? Okay, still going? Okay, good. Any questions about that at all? We okay with that? All right, wonderful. Let's move on. Now, let's talk about this next one. All right. So on this next one, we're not going to actually do the full-on problem. But what I want you to do is understand what is going on. Let's read this. We have $15,000 to invest. What's that number? It's your P, right? It's your P, right? It's going to be invested. So it's not the future value. It's what you're putting in right now in the present principal. Okay? So we have $15,000 to invest. All right? Everybody agree? Okay? It says, which of the two rates would yield the larger amount in 5 years? So what's our time component? 5, right? And what we're going to do with this is do what? We're going to invest it looks like, in 2 different accounts. Everybody agree? And see which one would be better. One of them is an interest rate of 7%, compounded quarterly. Are you following what's going on here? Right? One of the accounts is 7%, compounded quarterly. And just FYI, here's where the time component comes from, right? The other one is 6.91%. Compounded continuously. How come I don't have an n here? How come I didn't write n equals something? Because I'm going to use a different equation. That's good. I had to write continuously so I knew what to do. And essentially what this amounts to is what? A comparison between 2 problems, isn't it? Whichever one has the higher A at the end, the higher future value, is the account I should go with. Does that make sense, guys? So for this one, you're going to use the compound interest formula, which is solving it this way. For this one, you're going to use the continuous compounding formula, which is using this equation solved this way. At the end, you would compare your future values and see which one is better. Does that make sense, guys? Okay, so are there any questions? Does somebody want to see me set this up? I'll set it up for you, then we're not going to do it though. A equals 15,000, right? 1 plus your rate, 0.07 over 4, that's a little bit tight. Let me go rewrite this. Okay, so your future value is 15,000 times 1 plus R, 0.07 over N to the N times your time, which is 5. Isn't that exactly what's going on there, right? So we just set this up like we would one of those over there. There's your principal. There's your rate for this account. There's your number of compoundings for this option. And the time is the same, 5 years for both accounts. Now this one, you would not use this equation. You would use the continuous compounding equation. A, your future value equals P, the same 15,000. E, that's nothing but the E, your rate. This one's not 7%, it's 0.0691. Convert that to a decimal, times the same time though. And that's how you would do it. You would use the method up there to solve this, the method down here to solve this. Everybody got that? Any questions about that at all? I don't want to do it because you have several examples to do there. Okay? And at the end, whichever one has the higher future value is your answer. All right, let's take a look at this next one. All right. Now, how much money should be deposited today in an account that earns 4% compounded semi-annually so that it will accumulate to $10,000 in 3 years? Are we looking for future value now? No. We are not looking for future value. We're looking for what? Present value, aka principal, right? You want to know, hey, I have a financial goal. My financial goal is what? What's the financial goal here? 10,000, right? Your goal is $10,000 in 3 years. You found an account that will pay you 4% semi-annually. So if I want to have $10,000 in 3 years, how much do I have to put in now? We ask that all the time, right? So in order to solve this, there's one last formula for this section. Well, actually, it's the third formula. We have a fourth one. And the formula is P equals 1 plus R over N to the NT divided by A. All right? Oh, crap. I put it in the wrong direction. Sorry, not paying attention. It's A over 1 plus R over N to the NT. Not paying attention. Sorry. Okay? So here is formula, major formula 1 for the section. Here's 2. Here's 3. And we'll have a fourth one in a moment. That'll close out the section. Okay? So in other words, if they ask you, how much should be invested now? How much should be put down now? How much should we start the account with? That's this one, right? We're looking for the principal. It's going to be based on the future value, rate, number of compoundings, and time. Let's go solve this one. So in order to do this, why don't we do this over here? Your P is going to equal what? What's A? What's the A here?
10,000.
10,000, exactly. There's your A, right? So your principal, or what you need to put down, is going to be based on what your goal is, $10,000. All right, 1 plus R. What's R?
0.04.
0.04. There's your interest rate, 0.04. Divided by your N. What's N? 2. So you're semi-annually, so it's 2. Your N is 2. That goes in not just 1, but 2 places, and what is your t?
3.
3 years, right here. 3 years is your t to the 2 times 3 power here. Okay? So there it is. There's the setup for our problem. Now, we are going to go and solve this the same way we would over here. We would do this first, then add 1, then to the exponent, then we do the division. Let's talk about this. Here we go. And you guys are already working, so that's great. 0.04 divided by 2, what's that? 0.02 plus 1. 1.02. Oops, I just needed to leave that numerator there. My fault on that one. So I'm going to leave the numerator, that's 10,000, divided by 1.02 to the what power?
6.
6 power, 2 times 3. So that's what your next line of work should look like. Now, we need to figure out what 1.02 to the 6th power is. What is 1.02 to the 6th power? Somebody read to me down to like 6 or 7 decimal places.
1.126162419.
All right, wonderful. Now, why did I actually need to take a step and save this? Because is the problem going to be correct if I get that and then hit the division sign in 10,000? No, it's going to be backwards. Don't make that mistake. If you do 1.02 to the 6th power, get your answer, and then hit the division sign immediately, 10,000, it will be wrong. You will not get the right number. Okay? So that's why I had to save it, because we're going to have to type it back in. Does that make sense, guys? So now I'm going to clear out the calculator, put 10,000 divided by, or division sign, as many decimal places down. Does that make sense, guys? That's going to give me my answer. And what is the answer?
8,879.71.
Excellent job. And isn't it true that this number should be lower than the 10,000?
Yes.
It should be, right? Because this is what gets the count started. All the previous ones, yeah, it should be bigger because that's what it should end with. See what's going on here? Pay attention to that. This one's kind of your different problem because you're looking for the principal, not the future value. Principal should always be lower than future value if your account is growing. All right? And conversely, future value should always be larger than principal. Okay? Any questions about that at all? Okay? So it's right. I'm not going to type it in, but there you go. Okay? Now, looking at number 10, we have a very similar problem. I'm not going to do it. How much money should be deposited? You have a very good sample problem right there for you to go off of. Let's take a look at this one. We're not going to do the whole problem, but we're going to at least set it up. Okay? So let's take a look at what's going on here. LaDonna, is it still going?
Yes.
Excellent, thanks. At the time of her grandson's birth, a grandmother deposits $7,000 in an account. Let's pause for a moment. What's that? Principal. Okay. While you're reading, just note your pieces, right? It's not future value because at the time of her birth, she deposits, right? Deposits your key word that you know is principal. In an account that pays 9%. Stop for a moment. What's the 9%?
Your rate.
Your rate, good. Compounded monthly. Stop for a moment. Are we using this first one or the second one? First one, because they said compounded monthly. They didn't say continuously. So if it's monthly, what is that variable?
12.
It's 12 for your n. Does that make sense, guys? Okay, let's keep reading. What will be the value of the account? What does this phrase mean that we're looking for? A, good job. So we're looking for A at the child's 21st birthday. That's your time. What does the 21st birthday mean? Time is what? 21. Is this not a problem that we've been doing over and over and over again? Yeah, just masked with words. So let's go set this up. Your future value of this account is going to be $7,000 times 1 plus your rate, 0.09, divided by n, 12, to the n times t, 21 years. The answer to that will be how much that account grew to. A nice little birthday gift. Any questions about that at all? I'm not going to do it, but you can see that it's stuff that we've done over and over again. Okay? Questions at all? You okay? All right, wonderful. Let's go on. Let's read this. I'm not going to do it, but I just want to show you that it's another example of what we've been doing. In 1626, an explorer convinced a group of indigenous peoples to sell him an island for $26. If the indigenous peoples had put the $26 into a bank account, principal, right? Paying 8% rate, how much would the investment be worth in year 2005? How would we figure out the time? Those subtracted, right? If the interest were compounded quarterly, continuously, isn't this the same thing? Right? So I'm not going to do this one. I just wanted you to see that it's just another example of one of these problems. Now, okay, the last equation, and I never remember it, I always forget it, and you would think I would, is this fourth one is y equals, and I think it's 1 plus r over n to the nt minus 1. I think. But what I'm going to do is I'm going to help me solve this and then tell you guys one more thing. 1 plus r over n to the n. I shouldn't care about the t. Let me erase this. Now, on that note, I want to let you guys know that all of these formulas will be given to you on your test. You do not have to memorize them. Were you stressed about that this whole time? No, you do not have to memorize them. So this formula, this, and this will be given to you. This won't. You're going to need to know the difference, and I think that's pretty easy. You should be able to do that. But it's going to say compound interest formula and so on. So you need to know them in general, how to use them. But you don't have to memorize the actual formulas, okay? So this is the formula for effective annual yield, okay? So the formula is y equals 1 plus r over n to the n power minus 1. Let's understand this by working with it. It says a bank offers a money market account paying 8.9% compounded annually. All right, well, let's just write this down. We have 8.9%, and then your n is 1. Everybody agree? Okay, that's what we can get from the first one. A competing bank offers a money market account paying 8.1%. Compounded daily. What's daily for your N? 360. All right, assume 360. Which account is the better investment? Well, you might be wondering, how can you possibly compare them when you don't have a principal, you don't have a time component on it, right? How can you possibly compare them? Well, you can, using the effective annual yield formula. Yes, you don't. You can simply compare bank accounts, or not bank accounts, compare characteristics of the rate, so long as you know the number of compoundings, and that alone will be able to tell you which is the better deal. Does that make sense, guys? And I'll explain, I'll tie it all in to simple interest in just a moment. So, with that said, here we go. Y equals 1 plus your rate, 0.089, over n, 1, to the n, 1 power minus 1. There's your setup. Does that make sense, guys? Look at all the pieces. 1 plus r over n to the n power minus 1. Make sense? Let's go set up the other one, then we'll calculate it. The other one, y equals 1 plus your rate, 0.081, over your n. This time it's 360, right? To the 360 power minus 1. Okay? There's your setups. Are we all in agreement? That's how you set it up, at least based on the effective annual yield formula. LaDonna's still going? Perfect. All right, so let's go calculate it. Does this look much different from that? No, it's about the same. So 0.089 divided by 1, what's that? That's easy, right? What is it? 0.089. Then add 1 to it. What do you get? 1.089 to the power of 1 minus 1. What's 1.089 to the power of 1? 1.089. This one's the easiest one. And then if we subtract 1 from it, what do we get? 0.089. Bottom line is what? If you see a rate and just the n is 1, it's just the rate itself. But we need to go through that anyways. But doesn't that make sense? You get it once a year. If your annual interest rate is 8.9%, then sure enough, it should be 8.9%. But your answer, convert it by putting it back to a percentage. There it is. That was a long way of doing getting back to 8.9. But this one's not quite the same, is it? Okay, let's go do the other one. Many of you are already working it. 0.081 divided by 360. What did you get? What's what?
0.000225.
Perfect. So plus 1, 1.000225. Is that right?
Yes.
Any other items with it?
No.
Okay. To the 360 power, what's 1.000225 to the 360 power? What's that?
1.084361017.
Okay, perfect. If we subtract 1 from that, we get what? 0.08436 and so on. But all I need is what? 128.4%. You guys see what I just did there? Take a moment, look really carefully. I didn't need to go that far because I'm looking at the interest rates. I'm comparing the interest rates. What's up, Gideon?
If it was like 0.0845, would you round up that 4, or would you just?
What I would do is I would just go I would go a step further. But I knew to stop because I had enough to compare them. Does that make sense? I don't think they're gonna throw something at you that's that tight. But if it was, even if it was, I'd say 8.45% because this one is exactly 8.9. And I wanna know exactly, or near the exact. By rounding it up to 8.5, it might mess that up. Regardless, which one is the better account? The first one, right? Okay, the first one is the better one. The 8.9% annually is the one you want. Because why? The effective rate is higher. So let's understand what happens here. What does effective annual yield, this formula, tell us? It basically puts both accounts and converts them to simple interest accounts that are level playing fields. So it allows you to level the playing field even though the compoundings are different. It levels the playing field to a simple interest situation so that you can compare them equally. Does that make sense? Okay? And so when you get to those, that's how you handle it. I'm not going to do 14. That is it. Okay? So that concludes 8.4. We're going to go on to 8.5. Okay? And I need to stop this.